Welcome to Math with Miss Garrity. Today we're going to talk about factoring quadratics when the leading coefficient does not equal 1. So if we have a quadratic, for example, 6x squared plus 23x plus 20. I would like us to factor this. And when you factor a quadratic that's a trinomial, typically we want to get two binomials to multiply by each other to get the original. But when the leading coefficient is not 1, here is one way we could do this. I suggest multiplying the a value by the c value. And we get 120. We need to find factors that multiply to get 120, but then are going to eventually add up to 23. So let's start and do it methodically so we don't miss any. We've got 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, 10 times 12. But if you look, 8 times 15 adds up to 23. Okay, now we're not going to put 8 and 15 in here. What we're going to do is we are going to rewrite the original. We're going to leave 6x squared there, and we're going to leave 20 at the end. But now we're going to split 23x into two terms. We are going to split it into 8x plus 15x. So if you look what we did, we just wrote an equivalent polynomial to our original, but we wrote it with 4 terms. And when we have a polynomial in 4 terms, we factor by grouping. So, what is the greatest common factor of 6x squared and 8x? The greatest common factor is 2x. And when we factor 2x out of these two terms, we're left with 3x plus 4. Now, we're going to factor the second two terms. The greatest common factor is 5, and we are left with 3x plus 4. And this is exactly what we wanted to happen. Our new expression has a common factor of 3x plus 4. So if we factor 3x plus 4 out of these two expressions, we are left with 2x plus 5. And those are the factors of the original trinomial. And we can check our work if we want to by foiling. 3x times 2x is 6x squared. 3x times 5 is 15x. 4 times 2x is 8x. And 4 times 5 is 20. And when we combine like terms, we get the original trinomial. So factoring quadratics when a doesn't equal 1. Let's try another example. 8x squared plus 34x minus 9. We're going to factor this, and we notice the a doesn't equal 1. So we are going to end up trying to factor by grouping. So our first step is to multiply the a value times the c value. And in this case, they multiply to give us 72. So we're looking for numbers that multiply to give you 72 and add up to 34. So we start with our coming up with factors in a methodical way. 1 times 72, 2 times 36. Actually, I can stop there because 2 and 36 can combine to give you a 34. The 2 is going to be negative. So what I do with these two factors now is I go back and I split my middle term into those two factors. So 8x squared stays there. Negative 9 stays here. And now this middle term gets split into negative 2 and 36. So I should have actually put minus 2x plus 36x. Now I'm going to factor by grouping. 8x squared minus 2x have a common factor of 2x, and we would be left with 4x minus 1. 36x minus 9 has a common factor of 9, and when we factor a 9 out, we get 4x minus 1. And this is what we wanted. We've got a common factor of 4x minus 1, and when you take that out of each of these expressions, we're left with 2x plus 9. And again, if you would FOIL these two binomials, you get the original. So when we are asked to factor, this would be our answer. And there you go.